Hello everyone. Let's understand how Dijkstra algorithm works. Let's take an example of this graph. Here you can see there are total 6 nodes available, and this is the weighted graph because you can see there is a weight or the label given on the edge. So it's a weighted graph, and it is also undirected graph because there are no arrows given in the graph. So we are working on undirected weighted graph for this example. Now, in Dijkstra algorithm, we are finding the shortest path from the source node. Now here, let's consider this O as our source node. So this is our source node. And from this source node, we are going to find all the shortest paths to all the other nodes. Now, how to do that? Now, in the very first step, you have to consider the distance of all the nodes. Okay, now here, if you see distance means what? Given this node, what is the distance to travel from this node to this node itself? Or what will be the distance to travel from node 0 to 1, given cost 4? So here we have to calculate that distance. Now, in the very first step, all you have to do is you have to get the initial distance values. Now here, the initial distance value is for the source node we consider at 0, and for all the other nodes we are considering the distance of every node as infinity, because as of now I have not found, I don't know what is the shortest path from source node to this node. There are multiple paths, right? I can reach to one from this path, I can reach to one from this path, I can reach to one from this path. So which path is the shortest one? I can clearly see that this path should be the shortest one, not this one, right? So the distance that I need to cover from 0 to 1 is 4 basically. So how do I prove that? Now here there is one formula that we need to understand before we learn the Dijkstra algorithm. The formula is you need to uh, update the distances of any destination node. Okay, so here the destination node will be V. Okay, to any other node, because first node we are assuming at 0. So I need to find out the distances of all the other nodes. So if this is U, so all the other node becomes V. So I need to calculate the distance of V. Now, how do I calculate the distance of V? So it is nothing but distance of U, which means the source from where we are coming to that node, plus the cost of traveling from the source, which is U, to destination, which is V. Now here, let's talk about 1. I want to find out the distance of 1. So it is basically from 0 to 1, I want to calculate the distance. So 0 becomes U, 1 becomes V. Right? So let's say this is V. So this is the formula that we need to use to calculate the distance between the nodes. Okay, now in the step 1, so let's talk about step 1. So in step 1, we are starting from node 0. So I will just draw node 0. And from 0, I am going to node 1 and node 4. Now, why we are starting from 0? One thing is because 0 is the source node, and the minimum distance among all the distances in the graph, 0 has the minimum distance. That's why we are starting from 0, because it is our source node. So now we have to update the other node. So if this is U, as I mentioned, if this is U, so this is V and this is V. So if we want to replace this formula for 1 and 4, our formula becomes d of 1. So I want to calculate the distance of 1, which will be now d of 0, because I'm coming from 0th node, plus I need to find the cost to travel from 0 to 1, because 0 is my source and 1 is my destination. That means here d of 0, we already know, we have assumed initially that it is 0, and the cost to travel from 0 to 1 is 4. So the total distance to cover from 0 to 1, 0 to 1 becomes 4. Now here another catch is when you're calculating this d of v, and this d of v is actually the new weight, new distance that we have calculated. It should be smaller than the d of v old. That means if that node has any old distance, that should be greater than the new distance that we have calculated. And if this is so, we will update the node with this new distance. That means here, I have assumed 1 as distance infinity, but I can clearly see now distance of 1 comes as 4. And therefore, I'm going to update the distance of 1 with 4. Why? Because the distance between these two is cost 4 plus the distance of 0, which is 0. Therefore, 0 plus 4, which is 4. So this branch has contributed to the distance of 1. Similarly, this branch, we can see that the label on this edge is 8. So we'll write the formula for this node. We have to update the distance of this node. So d of 4. And how to get the distance of 4? From where we can come to node 4. So it is d of 0 because, because 0 is the distance plus the cost from 0 to 4. Right? So I'm calculating the cost from 0 to 4. So here the distance is 0 and the cost to travel from 0 to 4 is 8, and therefore the distance becomes 8. And I can clearly see both 4 and 8, they are minimum than the infinity value, and therefore these new distances will be updated on the nodes. So here it was infinity. Now I will delete that infinity and I will write 8 over here. Similarly here, this was, sorry, I will just write it properly. So this is 4. Okay. Now this is step 1. So in step 1, we explored node 0. And because we have explored node 0, let's mark it visited. So I'm just highlighting it with yellow color to just show that we have visited node 0. So this is first step. Now let's talk about the second step. So in second step, what you have to do is you have to focus on the remaining graph. Now, looking at the remaining graph, if I show you the remaining graph, only these two distances have been updated, others are still infinity. So if I want to take the remaining nodes, I am not going to consider node 0 because node 0 is already been visited now and it has been explored now. Other nodes have not been explored. So from the remaining nodes, that is 1, 2, 4, 5, 6, we have to find the minimum distance. Now, this has already been updated with 4 and this has already been updated with 8. So 4, 8, infinite, infinite, infinite. So I can clearly see that node 1 has the smallest distance, and therefore now I will use this node to explore the further branches. That means I will explore this node and then I will mark it visited. So from the graph, I can see that 1 goes to 2 and 1 goes to 4 with cost 6 and 7. So let's just draw that now. So I will draw here node 0. Then from node 0, we reached to node 1 and 4. And the distance of 1 is 4. Distance of 4 is, sorry, I'm just writing infinite. We have already updated this weight as 8. Now we are exploring 1, right? Also, we have already visited 0, so we're not going to pay attention to this 0. So I'm just highlighting this, that we don't need to pay attention. Now we are focusing on this 1. So let's explore the edges. So as I mentioned, 1 to 4, there is one edge, and 1 to 2, there is one more edge. And let me just confirm the weights one more time. So it is 6 and it is 7. So I will just write that. This is 6 and this is 7. So now here, this becomes your U and this becomes V. So we need to update the distances. This is also, now this is the old distance. We need to check if the new distance needs to be updated, right? So let's find out the distance of 2 and 4. So again, we will write distance of 2 that I need to calculate. Also, I need to calculate distance of 4. Okay. And again, the same formula, the source from where we are reaching to 2. So we are reaching from 1. So distance of 1 plus the cost between these two, so which is 1 comma 2. So this is 1 comma 2. Similarly, to node 4, I'm reaching from 1. So distance of 1. Also, the added cost, which is cost of 1 comma 4. And then we'll just replace the values. So here, distance of 1, which we have calculated in earlier step, which is 1, plus the cost between these two, which is 6. And therefore, the value comes as 10. Right? And the initial value of 2 is infinity. We had assumed earlier, right? So here it was infinity. So now definitely 10 is lesser than infinity, and therefore we're going to update the weights, right? Here also we have updated the weights. Here also we have updated the weights. Here also we will update the weights. Same for 1. Now we'll have to check with node 4 now, because node 4 already has some distance, right? So this distance from 1 is 4, because we knew the distance of 1 is 4, and the cost to travel from that is 7. Now this comes around 11, right? And this is the new distance. You have to compare, it has to be smaller than the old distance. What is the old distance? That is 8. Is this condition true? Is 11 lesser than 8? No. So here we are not going to update with the new distance, right? It will still remain 8, because this is shortest path problem. We have to find the minimum weight, minimum distance, and therefore we will not update this. So this is the second phase, and because we have explored 1 thoroughly, so 1 is visited now. So 1 has been visited. Okay, and these two nodes, now they have been updated with the weights. So now 2 has got uh, distance 10, and we're not updating 8. Okay. Now, next is now we don't have to pay attention to 0 and 1, because they have already been visited and explored completely. Now we have to focus on the remaining nodes. Now, what are the remaining nodes? 2, 4, 5, 6. Out of which 2 and 4 has already got some distance. So 2 has distance 10 and 4 has distance 8, and then 5, 6, which is infinity. So among these 4 nodes, we can clearly see that node 4 is the node with the minimum distance. So then we will, in step 3 now. So in step 3, let's just draw the graph one more time. And now we will explore the path from node 4. This problem takes a little time in solving, because you have to draw the graph again with all the weights and the distances. Do not forget to write all the weights and distances in every uh, step, it is very important to showcase that how many nodes have been explored thoroughly, and how many nodes are remaining. So I think this I have missed. Yeah. Now, so we have to just explore from node 4. Yes, because that is the minimum weight, 8, 10, and others are infinite. So we are not paying attention. Again, I'm repeating, 8 is already gone because it has been explored thoroughly. 1 is already gone because it has been explored thoroughly. Now it is time for 4. That means now we are going to explore 4. So from our original graph, we can clearly see 4 is going to 2 and 5 with 1 and 3. So 2, so it's going to 2, and then it is going to 5 with 1 and 3. Let me just cross verify one more time. Yeah, 1 and 3 to 2 and 5. 1 and 3 to 2 and 5. Now that means this is the source, that is u, and then these are the v values that we have to update. So let's calculate d of 2 one more time, because it is coming from 4th node, and d of 5 because it is also coming from node 4. Again, the same formula that we have to apply. 2 is coming from 4th node, node number 4. So D of 4, and the cost between these two. So if you see, this is how you have to remember the formula, right? So distance from where we are coming to this node, along with the distance, the cost between these two. Similarly, from where we are coming to node 5, again 4. Also, the cost between these two, which is 4 comma 5. So cost between 4 comma 5. So in writing ways also, then it's easy for you to remember. So now d of 4, we know the d of 4 weight, the distance is here, so I'll just write in both the places. Plus, here the cost of traveling is 1, so this comes to 9. And this is the new weight. What is the old weight? 10. So we to just compare this. Is 9 less than 10? Yes, sure. So then we'll have to update this. So this will get updated and this will become 9. Let's try for the next one. 8 plus 3. So this comes to 11. And because earlier the weight of 5 was assumed as infinity, but obviously 11 is lesser than infinity, and therefore we're going to update this weight also. So 5 will become 11. Okay. So till now we have explored these three nodes. So let's move ahead and do the next step, which is step number 4. Again, we need to draw the graph with the earlier updated weights, which is 1, 4. So you can clearly see I've started adding the nodes which we have started exploring in that step. So if you have enough time, you can draw entire graph in every step. So this is optional because I don't want to spend too much time in drawing the entire graph. So here I'm just drawing the nodes which I have added in that particular step. So this is done now, and the weights have been updated with 9 and 11. Also, I'll just make sure that I know that how many nodes we have explored so far. So till 5 this time. Now from the remaining is 2, 5 and 1 is 6. Right? Because 0 is explored, 1 is explored, 4 is explored. So we have 2, 5, 6. So 2 weight is 9, 5 the weight is 11, and this is infinity. So but obviously 9 is lesser. Right? So this node has a lesser value, so we'll have to explore this node. So 2 has only one edge, which is 6. Right? I forgot to mention that there are many other edges also to that node, but you will not consider those edges whose nodes are already been explored. So I can't explore 1 again because 1 has already been explored. Similarly, 4 I will not explore because 4 is also completely visited. Right? So you have to be very careful when you are, updating the links. You don't have to go backward to the nodes which have been explored. So here 2 is going to 1 and 4, but I'm not considering that. I will only consider 2 to 5 and 2 to 6. So I'm going to consider only these two edges because these two nodes have still not been visited. And we know that node 5 has weight 11 and 6 has weight infinity. Also, the weights on these edges, this is 4, 6 and 7. So I'll just write it down. 4, 6. Okay, sorry. I don't need to draw this because as of now, we are exploring node number just write it in white color. Wait. So that it's easily identifiable. What I will do is from 2 we are going to 5 and from 2 we are going to 6. So as of now we are exploring only 2. So I need only these two edges. And 6 has already assumed distance which was infinite value. And 5 we had updated in the earlier stage, which is 11. So let's find out the new updated value. So this is 7 and 4, the distance. Let me write it down. 7 and 4. Again, let's update the distance. So we need to calculate the distance of node 6 and we need to calculate the distance of node 5. Right? Again, how we are coming from this node? So we have explored these nodes because of node 2. So there is source which is d of 2. And therefore, we need to find the cost between these two nodes. So it will be plus cost 2 comma 6. And here plus cost of 2 comma 5. Now let's see if we can update the distances. So I can clearly see now I'm not writing the value here. 9 plus 7. So this comes around because the distance of 2 plus the cost to travel. So 9 plus 7, this comes around 16, and 16 is less than infinity. But obviously I'm going to update the data because infinity abhi nahi rahega. So then it is 16. Then from 2 to 4. So 2 has data distance 9 plus the cost, which is 4. So 9 plus 4, that is 13. So let's check if 13 is less than the old distance, that is 11. No, it is not, right? So this will not get updated. So only node 6 value gets updated. So 2 has been explored. Now the remaining two nodes, this is 11, this is 16. So in the fifth step, now if you see here in fifth step, entire graph remains the same. We're just exploring this edge because 5 is only now going to 6 because other nodes have already been explored. So last step is I will draw the final graph that we got in the earlier step. Do not forget to write the distances and the cost of every node. This is 9. This is 7. And this is 1. I think, yeah. Then this is 5, which is 3. This is 4, which is not getting updated, and then 6, which is 7. So this becomes 16. Now here, all these nodes have been, visited. So 0 is visited completely, 1 is visited, after that 4 is visited, after that 2 is visited, after that now remaining is the minimum distance node is 5, and therefore we need to explore it. And there is only one edge going from 5 to 6. So we'll have to check the cost, which is 6. So let's just write that 6. Now this becomes V and this becomes U. So we need to calculate the distance of 6, the new distance of 6, if it works. So now I'm not writing the formula. We know that distance of 6 is nothing but distance of 5 plus distance of cost of 5 comma 6. So distance of 5 is 11 and the cost of traveling to 5 comma 6 is 6, which comes around 17. So let's see if we can update it. So is 17 less than the old distance, which is 16? No, the condition is false. And because the condition is false, the distance of 6 will not get updated. So this is the final distances that we have got to travel. That means if you want to travel from 0 to 1, you will require distance. You will be covering distance 4. If you are traveling to 2, you basically covering 9 distance. Now how this 9 is coming? So this path is not correct for 2, but we will take this path to reach 2 because it gives me distance 9. So I'm exploring this path. So likewise, you are exploring different paths and you're getting the distance which is the shortest in this graph. Okay. So this is how Dijkstra algorithm works. Thank you.